When choosing between 1000-foot spools and 250-foot slinkies for Romex electrical wire, several factors come into play. Both options have their advantages and disadvantages, so understanding these can help in making the best decision for a specific project. Let's begin with the 1000-foot spools. One of the main advantages of using 1000-foot spools is less waste. Since the spools are larger, there are fewer ends to cut off. This is especially beneficial for long runs where multiple coils would otherwise be needed. Another advantage is that spools are generally easier to manage than slinkies, particularly when multiple workers are involved or when working in tight spaces. The continuous length of wire on a spool allows for smoother unrolling and pulling. Spools offer more flexibility because you can cut the wire to the exact length needed, which can significantly reduce waste. With pre-cut slinkies, one might end up with more scrap if the run isn't an exact multiple of 250 feet. Spools are also faster to pull through conduits or to fish through walls more efficiently than slinkies, thanks to the continuous length and ease of unrolling. Economically, spools typically offer a lower cost per foot compared to slinkies, which can add up to significant savings on larger projects. However, there are downsides to using 1000-foot spools. One of the main disadvantages is that they are heavier and bulkier, making them more challenging to carry and store. This can be a significant consideration on job sites where mobility is important. There's also the potential for tangling, especially if the spool is not handled correctly. Tangled wire can lead to delays and frustration, negating some of the efficiency gains. Spools are less portable than slinkies, making them less suitable for job sites where frequent movement is required. Now let's consider the 250-foot slinkies. One of the main advantages of slinkies is that they are lightweight and portable. This makes them easy to carry and move around, which is ideal for job sites with limited space or where frequent movement is necessary. Slinkies come in pre-cut lengths, which eliminates the need to measure and cut the wire yourself. This can save time and effort, especially on smaller projects. Slinkies are less prone to tangling than spools, making them easier to handle and use, which is particularly helpful for those with less experience. Slinkies are more convenient for short runs of wire because you don't need to unroll and cut a large amount. This can be a significant advantage when only a small amount of wire is needed. However, there are also disadvantages to using 250-foot slinkies. One of the main drawbacks is that there is more waste, as you have more wire ends to cut off, which can result in potential waste. Slinkies can be more difficult to manage than spools, especially for long runs or when multiple workers are involved. The shorter lengths can make it more challenging to pull wire through conduits or fish it through walls. Slinkies typically cost more per foot compared to spools, which can make them a less cost-effective option for larger projects. Slinkies come in pre-cut lengths, which limits your flexibility in cutting the wire to the exact length needed. This can lead to more waste if the run isn't an exact multiple of 250 feet. When evaluating which option is best for a particular project, consider the length of the runs. For long runs, 1000-foot spools are generally more efficient and cost-effective. For short runs, 250-foot slinkies can be more convenient. Assess the number of workers involved. If multiple workers are involved, spools can be easier to manage. If only one worker is involved, slinkies might be a better choice. Consider the space constraints of the job site. If space is limited, slinkies might be a better option. If space is not a concern, spools can be a more efficient choice. Evaluate the importance of waste minimization. If waste minimization is a priority, spools are the better option. If waste is less of a concern, slinkies can be used. Compare the cost per foot of spools and slinkies. If cost is a major factor, spools are generally the more cost-effective option. If cost is less of a concern, slinkies can be used. Consider the ease of handling and use. If ease of handling and use is a priority, slinkies might be a better choice. If you are comfortable handling spools, they can be a more efficient option. Think about the type of project. For larger projects with long runs, spools are generally the better choice. For smaller projects with short runs, slinkies can be more convenient. To summarize, 1000-foot spools offer advantages in efficiency, cost-effectiveness, and waste minimization for long runs, multiple workers, or situations where these factors are important. On the other hand, 250-foot Slinkies offer advantages in portability, ease of use, and convenience for short runs or situations where space is limited. Ultimately, the best option for a particular project should be determined based on the specific factors involved. One thing to think about to consider is if one is doing a big job, using all spools may be the better approach. Firstly, because it makes sure that one does not have to keep going back to the store to get more wire. Secondly, the price per foot is a lot better on the spools. Thirdly, it might be easier to pull and less waste because you can cut it to the exact length that one needs, as previously stated. If one is doing small jobs where one does not need a lot of wire, pre-cut Slinkies may be better. 1. Because there's not any wire sitting around when you are done with the job. 2. It is easier to carry around. 3. Less prone to tangling because it is already pre-cut in the specific length. It really comes down to preference. Some people like pre-cut lengths while some do not. There are many things to consider as said before, such as the length of runs, how many people are available, waste, cost per foot, and so forth. A recommendation would be to purchase both and see what works and what does not. By doing this, one can get a feel for both types of Romex electrical wiring and determine for themselves what is better. This is because everyone has different experiences, so it may come down to what is more convenient to them and the specific job that they are completing. The wire gauge is the diameter of the wire. In the imperial system, wire gauge is expressed as an American wire gauge, or AWG. The lower the AWG number, the larger the diameter of the wire. For example, 12 AWG wire is thicker than 14 AWG wire. The 12/2, 12/3, 10/2 and 10/3 Romex wire types refers to the size of the wire and the number of conductors inside the cable. The first number refers to the American wire gauge, or AWG, of the conductors. The second number refers to the number of current carrying conductors inside the cable, not including the ground wire. For example, 12/2 Romex wire has two 12 AWG current carrying conductors plus a ground wire. 12/3 Romex wire has three 12 AWG current carrying conductors plus a ground wire. The 10/2 Romex wire has two 10 AWG current carrying conductors plus a ground wire. And the 10/3 Romex wire has three 10 AWG current carrying conductors plus a ground wire. So when it comes to 12/2, 12/3, 10/2 and 10/3 Romex wire types, one of the main differences is the ampacity, or the amount of current the wire can safely carry. The 10 AWG wire can carry more current than 12 AWG wire. The National Electrical Code, or NEC, specifies the allowable ampacities for different wire gauges and insulation types. According to NEC Table 310.15b16, 12 AWG copper wire with THHN insulation has an ampacity of 20 amps, while 10 AWG copper wire with THHN insulation has an ampacity of 30 amps. Another key difference between these Romex wire types is their applications. The 12/2 Romex wire is commonly used for 15 amp and 20 amp circuits for lighting, receptacles, and small appliances. The 12/3 Romex wire is used for three-way switches and for some 240 volt circuits. The 10/2 Romex wire is typically used for 30 amp circuits for appliances like water heaters, clothes dryers, and air conditioners. The 10/3 Romex wire is used for 240 volt appliances that require a neutral conductor, such as electric ranges and some clothes dryers. When selecting the appropriate Romex wire type for a project, it's important to consider the following factors. Firstly, determine the load requirements of the circuit, including the voltage and amperage. Secondly, consult the NEC to determine the appropriate wire gauge and insulation type for the application. Thirdly, consider the environmental conditions, such as temperature and moisture, which can affect the ampacity of the wire. Fourthly, ensure that all wiring is installed in accordance with local electrical codes and regulations. Another factor to consider when choosing between 12/2, 12/3, 10/2 and 10/3 Romex wire is the type of circuit being wired. For example, if wiring a standard 120-volt lighting circuit, 14/2 or 12/2 Romex wire would typically be used, depending on the amperage of the circuit breaker. If wiring a 240-volt circuit for a water heater, 10/2 Romex wire would be required due to the higher amperage. It's also important to consider the length of the wire run when selecting the appropriate Romex wire type. For long wire runs, a larger wire gauge may be necessary to minimize voltage drop. Voltage drop occurs when the voltage at the end of the wire run is lower than the voltage at the source due to the resistance of the wire. The NEC provides guidelines for calculating voltage drop and selecting the appropriate wire gauge to minimize it. When working with Romex wire, it's essential to follow safe wiring practices. Always turn off the power to the circuit before working on any electrical wiring. Use appropriate tools and equipment, such as wire strippers, pliers, and voltage testers. Make sure all connections are tight and secure. Protect Romex wire from physical damage by routing it through walls, ceilings, and floors in a safe and secure manner. When making connections, use appropriate wire connectors, such as wire nuts or terminal blocks. Follow the manufacturer's instructions for using these connectors. Avoid over-tightening the connectors, which can damage the wires. After completing the wiring, test the circuit to ensure that it is working properly. Use a voltage tester to check for voltage at the receptacles and light fixtures. Use a circuit tester to check for proper wiring and grounding. By understanding the differences between 12/2, 12/3, 10/2 and 10/3 Romex wire types, as well as following safe wiring practices, one can ensure that the electrical wiring is safe and compliant with applicable codes and regulations.